In this video, we're going to analyze arithmetic sequences. To begin with, let's define what an arithmetic sequence actually is. So, it is a type of sequence where the difference in consecutive terms is the same or constant. That constant is called the common difference, and we use the letter D, or the variable D, to represent that common difference. So one of the first and most basic things that you could be asked in this lesson is, just given a sequence, can you determine whether or not it is arithmetic? So the question here is the sequence arithmetic? So let me give you a couple of examples. So if I give you a -4, 1, 6, 11, 16, etc., 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 we're going to try to find if it's arithmetic. Well, to tell whether or not a sequence is arithmetic, we have to see if from one term to the next the difference is always the same. So this is like our first term, this is our second, this is our third, this is our fourth, and they give us 5 terms. What I'm going to do is I'm going to see if I subtract consecutive terms, meaning I'm going to subtract a sub 2 from a sub 1, or I should say a 1 from a sub 2, if I get a common difference every time. So a sub 2 is 1, minus a sub 1 is minus a -4, which you guys know when you subtract a negative, it turns into a big plus. So the difference between the first terms is a 5. Now what I'm going to do is I'm going to compare the difference between the third term and its previous term, the second term. So if I subtract a sub 3, which is 6, from a sub 2, the 1, 6 minus 1 is also 5. Now just because those two happen to have the same difference of 5, you wouldn't want to just conclude it's arithmetic until we check all of them. So I'm going to subtract a sub 3, or the third term, from the fourth term. That would be 11 minus 6. That gives me 5. So far it's looking good. And then the last one I'm going to check is, what do I get when I subtract the fourth term from the fifth? That would be 16 minus 11. I still get 5. Notice how the difference is the same. That would be my common difference, D. And of course, since it's the same, we would say, yes, this is arithmetic. And the good news, in a second, I will show you if a sequence rather, is arithmetic. There is a nice formula you can use to get the formula for the nth term. Let's look at one more example. Let's say I give you 3, 5, 9, 15, and 23 as the first 5 terms of the sequence. Let's see if this is also arithmetic. If I do the second term minus the first term, that would be 5 minus 3 for a difference of 2. If I do the third term minus the second term, or a sub 3 minus a sub 2, that would be 9 minus 5, which is 4. Now right away, these are not the same, so I don't even bother checking the rest of these differences. As soon as the difference is not constant, I know this is not arithmetic. So that's the first thing you should be able to do, is see if the common differences are the same. If they are, we would call that an arithmetic sequence. Now, what is kind of nice is if a sequence is arithmetic, there is a rule to find the nth term for an arithmetic sequence. So the rule for an arithmetic sequence that has the following characteristics. If the first term is a sub 1, of course, that's always going to be our first term notation. So that's the first thing we need to know. And then the common difference from term to term, remember that's the d value. The common difference is d. Then the formula we can use is the following for the nth term. A sub n, the rule would be the first term a sub 1 plus n minus 1 times the difference d. This is going to be a nice formula to come in handy, and you probably could have used that yesterday when you were doing some of those rules that were arithmetic but didn't maybe realize it at the time. So let me show you an example of how we can use this formula, and I think you'll come to appreciate it. Example 2, let's write the rule. Write the rule for the nth term, and then find, let's say, the 15th term, a sub 15. Okay? We'll do two of them together. So for a, I have 4, 9, 14, 19, on and on and on. So hopefully you can kind of see the common difference is 5, right? Every time we get 5 and 5. So my d value is 5. My first term is 4. So that's all we really need to know. We're just going to plug it into the formula. So if I do, a sub n is the first term, a sub 1 is 4, plus, and then it's going to be n minus 1 times d, and in this case d is 5. Now I don't want you to leave your formula like that. It's not very pretty looking. You do want to distribute, so I'd get 4 plus 5n minus 5, and then I can add like terms here, giving me a final formula, and the best looking way of writing it, I think, is 5n, and then 4 minus 5 is minus 1. And if you want to check by using, first term n is 1, if you plug in a 1, it's going to be 5 minus 1, giving me a sub 1 is 4, which kind of matches what I have there. If you plug in 2, 5 times 2 is 10, 10 minus 1 is 9, that is our second term, and so on. Let's do one more. Let's say I give you 60, 52, 44, 36, etc., etc., etc. Now you might notice this one's a little bit tricky. The difference in the terms here is actually negative. I'm subtracting 8 every single time I jump a term. That is still arithmetic. The common difference, d, is negative 8. My first term is 60. So to write the formula, a sub n is going to be my first term, 60, plus n minus 1 times the common difference, negative 8. So just like before, I'm going to distribute, and I'll get 60 plus negative 8, and then a negative times negative is positive 8 there. If I add the common terms and rewrite it, I'm going to have negative 8n to start, and then 60 plus 8 is plus 68. What I like to do is just double check that this makes sense. If I use n equals 1, I'll end up with, I think, a sub 1 is 60, right? Negative 8 plus 68 is 60. So that matches my first term there. And you can check when you plug in 2 that it matches 2, but I think it does. Good.